fractions. To get us started, our joke of the day: what type of insect is good at math? What type of insect is good at math? If you were going to say an account, and you are correct. So an ant, an accountant, is the best type of insect at math. Getting started with different types of fractions, we're going to write whether each fraction is closer to 0, a half, 1, or 1 1/2. And if you want to pause the screen and work on these problems, and then we will get started. 2/10 is going to be closer to 0. It's 0.2. 0.2 is closer to 0 than it is to a half. 3/10 is also, 3/10 is going to be closer to a half. 0.3 is closer to 0.5 than it is to 0.0. 5 1/3 is a top-heavy number. There is a whole number right here. So it's going to be closer to 1 1/2. 6/10 is going to be decimal 6, which is close to a half. 9/8, once again, is top-heavy, and it's going to be closer to 1 because it's going to be actually 1 1/8. 1 1/8 is a lot closer to 1 than it is to 1 4/8, which would be a half. Top heavy again. How many times does 5 go into 9 without going over? Once, with a remainder of 4, so it is going to be closer to 2. 8/10, it is going to be closer to 1. 0.8 is closer to 1 than it is to 0.5. 15/8 is going to be closer to 2. If it was 16/8, that would be equal to 2. And 8/5 is going to be closer to 1 1/2, as it is 1 3/5, which is a little bit over a half. Looking at our math journal today, we're going to be taking a look at comparing a couple different of fractions. The easiest way to do it is to get a common denominator. Remember, the denominator is that bottom number. It's very easy to compare it because in this case we have both fifths, so we have two groups of pies that are both fifths, and it's easy to see that this one is actually going to be greater than 4/5. 3/5 is greater than 4/5. You'd rather have this much pie than just this little sliver. So 3/5 is greater than 4/5. Taking a look at another example, sometimes we're going to have different denominators, and you're still going to have to be able to figure out which number is going to, or which fraction is going to be larger. You can be using these clues to help you. The numerators are the same, but the denominators are not. They are the same size, but the parts are different sizes. Fractions with a smaller denominator is going to be the greater fraction. So the smaller of the pieces. Would you rather have your pie split into fifths, or would you rather have it split into sevenths? If you can see, it makes quite a big difference if we're taking a look at our wholes. So if our numerators are about the same, one different, but our denominator is quite different, 5 pieces versus 7 pieces, the one that is smaller, you're going to have bigger pieces. In problem number 3 is going to be neither the numerator or denominators are the same. So you might need to use a reference to compare. Is one fraction greater than a half? Is the other one less than a half? Each of the fractions in one fractional part is less than the whole. So the smaller the denominator, the larger the pieces are going to be. A very important thing that you're going to need to know and remember. All right, math message follow-up. This is part of your math journal. I'm not going to go ahead and complete it, as this is going to be something that you are going to work on in class activity. But be thinking about, are our denominators the same? Then we just need to look at our numerator. Or if our denominators are different, The denominator that is smaller is going to have larger pieces. And you're going to be using comparing with greater and less than symbols. Use this little chart to help you. Following up, problem 1, since the denominators are the same, the wholes are divided in the same number of parts. This means that the same size, so you need to compare the number of parts and decide which fraction is greater. In this case, we both have the same amount of pieces, but we have a different numerator of how much is shaded in. And I think you would rather have this much pie than just one. Taking a look at problem 2, just reiterating what was on the last page. If the numerators are the same but the denominators are not, this means that there are the same number of parts, but the parts may be different sizes. Remember, the fewer number of parts the whole is divided into, the larger the part is. So the smaller the denominator, the larger the pieces are going to be. Problem number 3, neither the numerator nor the denominators are the same, so you're going to have to use a reference, comparing it to a half. Is it greater than a half, less than a half, so forth. And number 4, each of the fraction is one fractional part less than a whole. Then the larger the part is, the smaller the denominator is. So if we're taking a look maybe here, if they were all of the pieces except for one, the more pieces that you're going to have, this is going to be smaller per part compared to this one. This is a larger section than this one, so you would rather have 4/5 of this one compared to the 5/6 of that one. So taking a look at a couple examples, which is greater, 5/7 or 7/10? You can think 7/10, 0.7, and then you just need to think of as your denominator here into sevenths, and you might realize that 5/7 is going to be more. 5/7 is closer to a whole than 7/10 would be. Looking at another example, 4/5, 13/6. This one is close. They're both equal away to a whole, but remember, the smaller the denominator, the bigger the pieces are going to be. Taking a look at this last example, 2/7 and 1/4. 2/7 is going to be larger. It's closer to a half than this one is going to be. Another way to compare fractions, which wasn't noted here, is to find equivalent fractions. So if I were looking at 5/7 and 7/10, maybe get them into common denominators. Remember, there's always the way to do the quick denominator, which would be 7 times 10 if we're looking at this example. So get it out of 70ths, each one out of 70ths. So how do we go from 7 to 70? That's multiplying it by 10. So we need to multiply the numerator by 10, which would be 50. 70 from 10 to 70 multiplied by 7, so 7 times 5, multiplied by 7, so 7 times 7 is 49. And you would see that 50/70ths is just a little bit larger than 49/70ths. So always can be using a quick common denominator to help you out as well. Here's an example again of that quick common denominator. So if I was looking at the numbers 2/3 and 3/5, I would multiply my denominator of 3, denominator of 5, so 3 times 5 is 15ths, and then I need to rename with equivalent fractions. So how did I go from 2/3 to 15ths? So 3 times 5 is 15ths, so you have to do that to your numerator. 2 times 5 is 10. Do the same thing for the second fraction, and you could easily compare, since now we have the same denominator, we have 10 versus 9, we know that 10 is greater than 9. You can go ahead and pause the video at this time as you go ahead and work on the 4 bottom problems. Looking at 3/4 and 5/8, if you were to find a common denominator of 8, it would be 6/8. And 6/8 is greater than 5/8. looking at another example, quick common denominator is 54, so it'd be 9 54ths and 12 54ths, and so 2/9 would be larger. Common denominator for 5 6 and 3/4 is 24, so it'd be 20 24ths and 18 24ths, so 5 6 is larger. Common denominator, again, 54, so times 6 would be 36, times 9 is 45. 45 is greater than, so 5 6 is greater than 6/9. This is going to be your math page that you're going to be completing during class. You really make sure that you're thinking about one of those ways to find it. If they already have a common denominator, then you're just looking at the numerator. If you're looking at how many pieces away they are from a whole, comparing it to a half, otherwise using the quick common denominator. I'm not a very visual person and trying to figure out what it would look like and to figure out sizes. So the best way that I always do is just find a quick common denominator to compare two fractions. You're also going to have page 249, which is going to be a little bit of a fraction review, adding fractions and doing some fraction sticks. So you just need to be filling in the blank space stuff of what it is asking. And then you're going to need to, down below, you're going to figure out what each fraction is equal to decimal. Remember, decimals, it's easiest if you get it out of tenths or out of 100ths. That way you can easily solve those types of problems. And that is all that lesson 8.1 is on. I wish you the best of luck, and I look forward to speaking with you about this lesson. Our biggest thing is continue to use that quick common denominator by multiplying the two denominators and finding their equivalent fractions using it, and then you can easily compare fractions.